And now we see the change. It happens, it reaches a certain key point of duration or power or something, and then suddenly a dramatic morphological transformation. You are seeing it live. This frequency is 1174 Hertz square wave plus the 11th harmonic. And Paramecium caudatum are a resilient organism which seem to require at least 4 minutes of exposure to a frequency. The power levels I've been using are about 125 watts. But after about 4 minutes, you will begin to see a change in the organism. Of course, it will already have stopped swimming about 90 seconds to 2 minutes after you reach a sensitive frequency for the organism. So this was a Paramecium caudatum undergoing an experiment with a Rife-Bare plasma device. Input into the Rife-Bare device 1174 Hertz square wave plus its 11th harmonic. The 11th harmonic is 12,000. The 11th harmonic is 12,914 Hertz. If you look carefully, you are seeing a live transformation of a Paramecium caudatum caused by a Rife-Bare plasma device at 1177 Hertz plus the 11th harmonic. The beautiful colors you're seeing are courtesy of the DIC filter on a BX60 Olympus research microscope. When you hit the right frequency, you need about 240 seconds before these morphological transformations begin. You may also need a certain minimum power level. What you're seeing now is happening at just short of 125 watts. Very close to 125 watts. And we see a protrusion below and left from the membrane. Some small organisms are swimming by and are not disturbed by this frequency. Inside the paramecium you can see lots of vibrating little sparkly action. Morphological transformation of the Paramecium caudatum caused by a Rife-Bare plasma device. And you can see we continue to witness ongoing changes. Look at the upper right part of the organism. witnessing a live morphological transformation of the protozoa Paramecium caudatum, caused by a Rife-Bare plasma device, 1180 Hertz, plus the 11th harmonic, 130 watts of power. Looking along the top, you see several sphere-shaped protrusions emerging from the organism. And changes in the shape of this organism will continue. (1180 Hertz plus the 11th harmonic, 12,980 Hertz. Both are square wave inputs into the radio frequency transmitter, which is connected to a plasma bulb filled with helium gas, a phanotron plasma bulb. The RF transmitter is custom made by Plasma Sonics Limited. It's called the OM1. It's a special radio frequency transmitter with a carrier frequency of approximately 27 megahertz and features amplitude modulated signal with an index of modulation higher than 1. So the output is a series of pulsed radio frequencies. Look at the upper left, we see material being ejected from the paramecium. And it's becoming quite round in shape. And we saw now emerging what was a protrusion, a sphere protruding from the body, now merges with the main body once again. We have seen fusion of these spheroids before in similar experiments. Here we have a paramecium caudatum changing in real time. Morphological transformation of paramecium caudatum. The present frequency is 1173 Hertz plus the 11th harmonic. It began to change after about 3 minutes 3 to 4 minutes of exposure and it began to change. Power level approximately 125 watts. It's continuing to change. I'm adjusting the filters in the microscope to see if we can get a little better view. You can see some small spherical organisms swimming by completely unharmed by the frequency. We're going to observe this organism for a short time and see if any more changes occur. You're seeing a morphological transformation of a Paramecium caudatum caused by 1175 Hertz, and it looks like we may be getting membrane ruptures in this organism. It's continuing to undergo some kind of change. Now we can see the perimeter of the organism better. Morphological transformation of Paramecium caudatum. March 6th, 2009. This is a Paramecium caudatum undergoing a morphological transformation. You're seeing it live. The shape is already starting to distend. I'll try to keep the organism centered. He's moving a little bit as he's changing. That's just an alarm warning me to let my amplifier cool off. But first, let's document these changes, which are quite interesting. When an organism stops swimming, that's a sign you're in a sensitive frequency range. Then when the organism starts to jitter or twitch, I would say a kind of a back and forth twitching like you're seeing now, it's a sign that it's undergoing or is about to undergo morphological transformation. The Rife-Bare plasma device is between 5 and 6 inches away from the microscope slide where these transformations are happening in real time. This organism stopped swimming at 1175 hertz. Now you can see it looks like a small rupture at the bottom. And when I changed to 1176, it began to change shape. Within 140 seconds, it was already, really 130 seconds. So within about 2 minutes, it will begin to change shape if you are on the right frequency. Notice these small organisms, which are small swimming spheres that share the space on the slide, and they swim by and are unaffected. Here comes one now. Swims by, touches the paramecium and swims off. There's another. They are unaffected by this process. So it seems to be frequency-specific process. It looks like a membrane rupture occurred out the bottom of this organism. Just changing the lighting a little bit to see what might be revealed. Stand by. There's a beautiful photograph. That's a live video image from the microscope. And I think it's quite interesting because of all the activity that you see inside the organism. Let's see if we can get a close-up of some of that activity. I don't know if this will show up on the video. It's a fascinating display of colors caused by different refractions of light caused by the DIC filter. And you see just a constant activity of some kind happening within the organism. Possibly membrane proteins are vibrating, or some component of the organism is in vibration, vibrating in sympathy with some component of this experimental frequency device. This view seems to show us, that's the same organism, and it seems to show that down in the bottom right, or somewhere there's been a rupture in the internal material is now spilling out. I believe it's down here in the bottom right. And you can see material venting from the paramecium here. What Royal Rife might have called a devitalization. That is not a normal, healthy paramecium capable of its normal function any longer. Frequency-specific effects on protozoa. 1175 hertz seems to be a very good frequency. Here we have 3 organisms side by side in various states of change. Let's see if we can get them all in the view. I don't think so. There's one here, they're in a straight line. This one's above it, and this one, and they're all undergoing a change right now. And there's a 4th one sneaking into the picture here, who also seems to be going quite slow. I'm going to try to, I think this one's going to change first. Let's take a look at that. Yes, we're going to see a change in this organism. Maybe I can do a close-up before he changes. Let's see if the camera will pick this up. This is a Paramecium caudatum undergoing a morphological transformation. Now you see at the bottom of the picture, he's starting to change very dramatically. And look at the left side of the organism now. All around the perimeter of the organism, we begin to see he's changing shape. 1175 Hertz seems to be a very effective frequency. And if you look inside the organism, you can see quite a bit of interesting activity. Something is vibrating very actively inside the organism. We're going to continue to watch this organism. The changes are happening a little bit slowly here. I'll increase the power level just a little bit, just a little over 125 watts. We begin to see membrane protrusions out the right side. Just changing the focal plane so you can see a little bit better. Watch carefully, we're seeing some dramatic changes happening in this organism. I'm going to change the lighting a little bit to see if we can highlight what's happening. Morphological transformation of the protozoa, Paramecium caudatum, caused by a Rife-Bare plasma device. A lot of internal activity in this organism. We'll adjust the lighting a little bit. Just changing, I'm adjusting the DIC filter, and I think it's absolutely fascinating, the sort of flashing imagery that's happening from inside the organism. as I change the DIC. And now we just saw a big shift in the shape of the organism. (1175 hertz). Continues to change. And very likely other organisms on this slide are also changing at the same time. Now I want to show you 3 or 4 organisms who are in something of a line on the microscope, who all went through a change about the same time at 1175 hertz. Let me go up to the next level of magnification. This organism changed while I was watching through the scope, and at the same time, this is the one we just filmed, changing, and above that, this organism changed, still moving, and above that, this larger organism changed. And this one looks like it developed a rupture in its side wall. So several changes happen simultaneously, and when you're trying to capture them on video, it's difficult to follow more than one at a time. This one's continuing to change. We have a Paramecium caudatum changing shape. Try to center around your screen a little bit. This change is happening very quickly. Sorry, I'm having a little trouble getting that to show up on the screen now. There we go. The camera is a little messed up here. I'll have to adjust the camera. We missed it, but it was 1169 hertz, and it was a very quick change. Paramecium caudatum, morphological transformation, 1169 hertz square wave, plus the 11th harmonic. You're seeing what's left of a Paramecium caudatum after a morphological transformation caused by a Rife-Bare plasma device. Let's see if we can get some good colors here. The colors are caused by a DIC filter, type of light polarizing filter. And it allows you to highlight various aspects. I think this organism is still changing shape. You can see some activity down at the bottom half of the organism. There is some activity down there. How close can I get? Let's see. Change the focal plane a little bit and see what shows up. Now, notice that underneath this paramecium, there are many, zooming in and out of the picture, are many small spheres. These are not paramecium, these are another organism. And they seem to be unaffected.